Hey, I'm Mark Bradford with Snowflake, live here in Portland. Before I get talk about what Snowflake is, I thought I'd kind of just get a gauge of the room, understand who I'm speaking to, because if you don't really care too much about the back end of Power BI, I don't want to go too deep there. So first, how many people know what Snowflake is? Pretty good level. That's pretty good. All right. How many people? Yeah, right. How many people know SQL? No SQL. Yeah, we're definitely in the Microsoft user group here. And then how many people are responsible for some part of your database, data warehouse? Like you're a DBA, a data engineer. All right, cool. All right, so fairly technical crowd. That lets me have fun. So all Snowflake simply is a relational SQL-based data warehouse that was built for the cloud. So if you're a Power BI user, there's a native connector. You just connect directly to Snowflake like you do pretty much any other database. I always like to start with kind of where we were born from, our origin story, when I talk about Snowflake, because you're all data people. You know what's happened, right? Data has become critical, not just to staying competitive, but for staying relevant, right? We can think of entire industries that have been upended because some data company entered the market and changed everything. So we know data is critical. At the same time this is happening, the amount of data out there, right? The volumes are just, probably all seen the statistics, it doubles every 1.2 years, the amount of data that exists. And a lot of this data, this new data, isn't clean, structured data from a business application. It's semi-structured. So it's from things like click streams or mobile app usage or IoT devices. And it's not something you can just easily issue SQL against and query me in your main way. I see some people nodding because they've probably had to parse JSON before, right? Yeah, it's awful. So the variety of data is a challenge as well as the volume. And then there's velocity component as well, right? Because there's more and more people who want data, they want more of it, and want it faster. I'm sure you've built dashboards. You take to someone and they're like, wow, this is amazing. They never say, I never want to see this again. They say, no, I want this every day. And by the way, that made me think of 2 or 3 other questions that I have for you now. So the more data you give people, the more it tends to kind of feed that appetite. And all this volume velocity, variety velocity has been really fed by the internet, right? And I think that's even caused kind of a certain expectation about how fast we can get answers. Because if you or I have a question, what do? We pull out our phone and we Google it. Well, maybe you guys are really hardcore Microsoft people and you Bing it. I don't know. But there's an expectation that if you have a question, you should be able to get an answer quickly. And we know that's oftentimes very hard because the data just isn't ready yet. That's oftentimes the hardest thing about answering the question. Power BI is an incredible tool. You can do a lot with data, but first you actually need the data. So the internet's created kind of this problem. I think the internet has also given us a solution in terms of the cloud. With the cloud, we have nearly infinite storage. We can throw as much data as we want in there, and nearly infinite compute. So we can process that data, whether we're loading it in or issuing queries against it, which is what you do when you're using Power BI. So that's where we come from. What makes us different than any other technology out there is Snowflake was not something that existed prior that was ported to the cloud. It was born in it. Our origin story is we were developed by, look at our founders, 2 of the lead architects from Oracle. These guys hold 130 patents between them. One of them holds the patent for materialized views. For example, these are hardcore data guys. They were actually tasked with taking Exadata and put it into the cloud. They started down this road. They're like, no, wait, we've got too many legacy limitations. Let's throw that away and build something new. And Larry said no, so they left. And they founded a guy named I can't remember, Bob Mugula. Bob was a longtime EVP at Microsoft. He gave the first demo of Microsoft SQL Server, and they founded Snowflake with this idea that hey, let's start fresh. Let's take advantage of the cloud. So we've only been GA since 2015. Since then, almost $1 billion in VC funding. You go on Gartner, Forrester, Dresner, you'll see we're a leader. I'll just name like the #1 startup by LinkedIn, #2 cloud company by Forbes. There's a lot of cool hype, which is fun. I think it's actually 2,500 active customers in the local area, like Discover.org, iOvation, certain sports apparel company out in Beaverton runs 90% of their workloads on Snowflake. So good like local. Gotta be big. Good local presence. OSU is another one I work with, which has been a lot of fun. So a lot of you may say, well, I already have a data warehouse. Why do I need Snowflake? One of my favorite movies. I had to throw a reference in. But yeah. And so there's 3 general problems that we tend to solve. The first one is silo data. I'm sure you've heard before, like, oh yeah, we've got data living all over your organization. Yeah, that's part of it, absolutely. Some different applications, it's hard to kind of bring all together. There's also that idea I mentioned before of the semi-structured and the structured data. Well, oftentimes people came up with this idea called the data lake, where you just throw your semi-structured data into that, and then probably just sat there. It was hard to kind of combine those together to do actual analysis on it. That customer shared one of my favorite lines is, we built a data lake, and now we can drown our data even faster. So those things tend to be siloed. And then even within organizations, you might have some data that'd be valuable for somebody else to see, like you're in HR, but you can't just share all of it with them, right? Because there's sensitive parts to it. You want to share a subset. That gets even augmented further when you think about the data that lives outside your organization, right? There's data with your vendors or that your customers have that'd be really, really useful if you had a very easy way of exchanging and collaborating and breaking down those external silos. But usually it involves some kind of FTP. You're sending over CSVs. They're out of date as soon as you do that, or APIs, which are always fun to maintain. So that's what I say when I mean siloed. Scalability and speed issues, right? Especially handling peak periods. You have to figure, okay, we're going to size this thing. What is the biggest period we're going to need, and how much do we want to really pay for that? Usage of data isn't constant through an organization. You're using a bunch when you load it in, and then first thing in the morning when everyone's running your Power BI report, right? Why is my dashboard running slow? Well, it's because everyone is running that report right now. That's why. For those of you who have to maintain database systems, there's a lot of things like indexing and vacuuming and partitioning and just these like manual tasks that take time. And if you want to expand, there's generally a big planning exercise, right? To decide how much more do we want to buy. So I disagree with marketing. I don't think this is a problem. I think this is a symptom, but it does lead to the slow decision making. So what Snowflake does is a concept of shared data, where you can bring together not only your structured data, but your semi-structured as well. Don't need to parse it. We'll just throw it in there. And we've got a variant type, and very easily now you can just join that with your structured data, get the complete picture. People who have done this before, this is like magic. And it helps break down those silos. So you can now actually seamlessly share data both internally and even externally with partners out there. All that data is in one spot, and you can then spin up your compute resources against that. In fact, you can spin up separate compute resources that will never cross over each other. So that means you can be loading in tons and tons of data with a massive ETL job at the same time you are doing analysis on the data, and there will be no impact. If you've ever had the experience, we have to wait until the data loads up, or wait until our nightly ETL loads overnight. That's this problem to solve. Or if you've got multiple groups, like a data science team, who every now and then just uses up all your resources because they got to run something big, they can have their own separate compute instance. They're all working on the same copy of the data, but no one else is impacting. And even better, it is elastic. So you can scale it up when you need it, and down or even off when you don't. And that's one of the nice things. There's a lot of solutions out there that can scale up pretty easily. They don't always scale down. So what tends to happen is like, okay, we need to bump up to the next level. you grow up, and now you're just paying a lot more for a capacity that you aren't always using. Should mention, this is simple. You know SQL, you know Snowflake, ACID compliant, ANSI SQL, works with all your familiar tools, including PowerBIUG. How are we doing on time?
Got a couple minutes.
All right. So just to give you an idea into what this looks like I mentioned, you throw all your data in there, you spin up those little cogs or kind of your compute clusters, you select the size you want, which we abstract to t-shirt sizes. And if you needed to, you could very easily say, oh, so many clicks here.
Snowflake's easier than this, right?
Yeah, it's easier than I could say, hey, I want to size up my data science job to an extra large. It's now an extra large, and when I'm done with it, I can turn it back down, even off, and this happens instantly. Yeah. Yeah. Have you used Snowflake? Oh, awesome. Okay. Yeah. That's what it is. It's a drop down or command line, so you can strip this out even if you want to automate it. And then for concurrency, maybe you don't need more processing power. You just need it kind of load balanced. You can also run multi-cluster. So it automatically senses, so there's a whole bunch of people trying to run this queries and spins up multiple instances against that. These are kind of, I think, neat things. I mentioned it brings in a semi-structured. Any of you ever had to work in a dev environment, right? Think about you're usually creating like a little sample of that. Snowflake has a concept called zero copy clone, where you can just say, hey, create a clone, create a snapshot of this data. And now you can work on this complete production data without ever actually copying it. All we are doing is just keeping track of the changes. So very easy to get your sandbox up and going. You can commit that back to production if you want to, or just turn that clone off, and like I said, you're no longer paying for that. So it makes that whole kind of working in the sandbox really easily. I mentioned the data sharing. We've got something called the data exchange. We can actually now go and get data from other companies like weather data, demographics, marketing. Nielsen is using this at a massive scale. But I'm really, really excited about this, especially for like the public sector, where I think we can solve some huge problems. You get, government entities working with, imagine, City of Portland working with TriMet and PSU on a project, for example. That's kind of what I'm envisioning.
Or you're working with a consulting firm and you want to share your data. You don't want to open up any ports.
That's a fantastic. We actually have actual customers who say we love this because we can give access to a third party who have specialized skills to bring in to work on a subset of our data, and we don't need to worry about how to give them access or what part they can see or any of the other kind of issues that normally come along with that.
Nice.
Yeah.
So can you make REST API calls and stuff?
100%. Yes. Yeah.
But then there's no modeling tool to match the data type.
For what use
Suppose
case?
you get something in a JSON file, another feed from an XML file or a CSV file, so you don't have to organize the data to.
No, you still do your modeling, right? So you'd still use like Power Query or something like that to run SQL against it, or just straight SQL, or if you have Informatica, you could use that. So that's what you can see. We work with all those just standard tools out of the box. Or if you're in data science, you work with all the native connectors for Python, R, Databricks, all that good stuff. The time travel one is pretty neat, where you can actually instantly go back to a snapshot of your data at a given point in time in 90 days. So if you accidentally drop a table and you want to go back to it, this is also very commonly used for like, hey, we just did all of our reconciliation. We want to make sure to go back and make sure the numbers look good. This is actually a test done with PowerBIUG, and that would be the report done by West Monroe Partners. But they did a performance per dollar analysis of Snowflake. The nice thing is, this is just, like to your point, you just kind of throw the data in. Yes, you do want to model it. But all of the like knobs you have to turn with a lot of the systems out there just don't exist. Snowflake, you just don't have to do them. What's that?
Less maintenance.
Yeah, less maintenance and less just time. Spent more time analyzing, less time working on it. So that's my bit. Off cards.
And we also have a sign-up sheet that we'll be passing around if you want more information to meet with Mark.
Yeah. I saw this group loves swag, so I also have these coffee mugs because I think you guys already tore through my notebooks and pens. So